Okay, this will be the last video clip of this exercise 6A. So let's go back to page 9 and take a look on answer number 4 first. Okay, it is given that P very directly as the square of Q, the square of Q. Okay, pay attention to this one, the square of Q. Too ugly, sorry. The square of Q. Now, if Q increases the value by 50%, find the percentage change in P. We haven't discussed a question like this before, but actually it's not that difficult. Try to follow it step by step. Because P very directly as the square of Q. That means the equation looks like this. Therefore, P equals to K times Q squared, where this K must not be 0. Okay, then we start to deal with the increase of Q now. Okay, so now we can say that the new value of Q. Okay, let me give this Q a new symbol, a capital Q. The new value of Q equals to capital Q will equal to small q times 1 plus 50%, because the question said it is increased by 50%, so 1 plus 50%. Then that means actually this capital Q will equal to 1.5 small letter q. Okay, so now we go back to the value of P. The new value of P, you can say you can let it to be capital P, but not that obvious, so I skip this work. Will equals to, according to the questions, according to this formula, should equal to K now times capital Q squared, because this is new value of P, not the original value. The original value is actually this one, K times small q squared, but it is now K capital Q squared. And of course, we substitute this 1.5q back to this one. Then we can have K, pay attention to the bracket here, 1.5q, and then square. And then take square. So altogether, after calculation, perhaps you can find out that it should be 2.25 kq squared, right? I just do 1.5 squared, it will be 2.25. Correct. Okay, so now we go back to the percentage change. Percentage change in value P should be what? The formula of percentage change. You've learned it in Form 3. Something times 100%. Okay? The new value of P minus the old value of P divided by the original value of P, and then times 100%. Okay? New minus old divided by old times 100%, regardless of whether the new value of P is smaller or larger, because the positive or negative will indicate it is increasing or decreasing. So we always use new value minus old value divided by old value times 100% here. So we substitute everything back into this percentage change formula. Then we may have to... Oh, this is so difficult to write. We may have 2.25 kq squared minus the original one, kq squared, divided by the original kq squared times 100%. And not surprisingly, after we factorize kq squared out, we can have this one, 2.25. Jesus. 2.25 minus 1. Okay, I factorize the KQ square out to the back. Okay, so now perhaps every one of you can see why I would like to factorize it out, because now the KQ square is completely cancelled by each other. So altogether, what left in the expression is 2.25 minus 1, 2.25 minus 1 divided by 1 times 100%. So actually, after your calculation, it should be a positive 125% for this question. Okay, remember to show positive or negative to indicate whether it is an increase or decrease. Okay, so you can do this to every question, like you use these skills to every question like this. You don't have to be afraid of the unknowns, because after all, at the end, it will be cancelled out completely altogether. Okay, so what left will be only numbers, okay, or the unknown, or the variation constants will be cancelled out, so don't worry. Okay, so it's your turn to try. Okay, now go to exercise 6A and finish question 13, 14, and 20 to 23. Okay, finish them all, and this is the whole chapter, exercise 6A. And also, please go to supplementary exercise 6 to finish question 5 to 9 and 25 to 26. Okay, so this will be your homework tonight. Supplementary exercise 6, question 5 to 9, 25 to 26. Okay, so please do every single question here. Thank you.